Now for our first speaker, Mr. John Noyle. He was the past president of Nashville Board of Realtors, and he is the president of John Noyle Investment Real Estate Company. He is the president of Southern Alliance for Clean Energy, and he is on the board of Climate Institute in Washington, D.C. Dr. Mr. John Noyle.
I think it's on. Okay, thanks. Well, folks, thank you very much for having us tonight. And Lisa Beard, I appreciate you putting this together, and all of those that are helping you tonight. We'll hear both sides of what I believe to be the most formidable challenge in your lives today. And how we deal with it will affect life itself. Regardless of what side you all find yourselves on this issue, it's only one Earth, and we've got to take care of it, and we depend on it. When I graduated from high school, I hate to tell you this, it was in the 1960s, the early 60s, and weather at that time was a best guess. TV weathermen were often the butt of bad jokes, and we predicted weather through willy worms and Groundhog Day. Now, when the Weather Channel says it's going to rain tomorrow at 12 noon, we bring our umbrellas. A lot has changed. We are living with a complex science, satellites and seismographs and text messaging and all sorts of things, and also in a coordinated climate in a data world worldwide. Recently, the U.S. population, are we still here? Okay, all right, hit 300 million, and back in November 20th of 1967, it was 100 million. So in that short period of time, we have leaped in the United States from 100 to 300 million. President Lyndon Johnson was then the president. A gallon of gasoline in 1967 was 33 cents a gallon, and a new home sold for $25,000. This wasn't long ago. And things have changed, and now the world population in its entirety is 600 billion people. And the planet is under pressure, and it's warming. Now, this should be understandable in some ways about the pressure. Coming from a very small population in the world and to a larger population in the world, we have put a lot of things on the planet that produce carbon. We've got cars. Can we get the ring out of this? Is that possible? Okay. No. What do you think, Roy? That's good. Okay.
Turn him down some.
Great. Thanks. Is that better? We good? Okay. Thanks, Roy. If we understand all these pressures now, that we're putting all this carbon out, it's amazing if you really think about everything that adds up. You've got power plants that put things out, you've got cars and all sorts of things that are putting pollution into the air. Now let me tell you something about a thing called the IPCC. The International Panel on Climate Change was put together back in 1988. And the importance of this is that there were climatologists, meteorologists, geologists, all got together and decided from 120 different countries of how they were going to deal with the issue of global warming. Some weren't really sure about it. But over the time and over the years, these people came together and had a report. And the IPCC just released its 4th report this past month, confirming the previous findings and asserting that almost everything frozen on this earth is melting now. We are rapidly warming, and CO2 is the highest level that it has ever been in 650,000 years. How do I know that? I'll explain that a little later. And CO2 is the primary cause of global warming. And here's how it is. Now, Roy, I know you're going to have a thing on this, and I'll try to cut this short, and you can round it out a little bit more. But here's what warming is about. Many of you may know this. But what you have is you have an upper atmosphere on the Earth. And the sun comes down through that atmosphere and hits the Earth, and it bounces back up. Now, depending on what the composition of the gases are in this umbrella that we have up here, above the Earth, these gases can escape partially. But if there's too much there, they can't get out enough and they'll bounce back. Now, they're very important to be there, and it's important to have some of those gases up there, because if it wasn't there, when the sun comes down, hits the Earth, warms the Earth during the day, and there was nothing there, then it could turn 60 degrees colder in the nighttime. So what we want is some of it to get caught, so that we can have it cools down at night, but it doesn't cool that much. 60 degrees would be a lot. So what is happening now with the CO2 gases that are coming up there, the International Panel on Climate Change, these 120 different countries, scientists from all over the world have agreed that it is catching this heat and not letting it out fast enough. Hence, the world is beginning to warm. Now, there are other causes that the world can begin to warm, but that is a functional and a direct cause where we can trace it right back to us, where we can say we are, in fact, the cause of this warming. We produce all these things that burn. By pumping the excessive greenhouse gases into the atmosphere, we're preventing too much heat from escaping, and it throws the energy balance of the Earth out of balance. So if CO2 is the main culprit, CO2 consists of burning fossil fuels, and those are particularly coal, oil, gas, wood, and a few other things. All this dissipates very slowly. Here's some facts. The National Academy of Scientists states that the Earth's average temperature has risen 1 degree Fahrenheit in the last century. Doesn't sound like much. With an accelerating rate in the past 2 decades, greater temperature increases at the North Poles and the South Poles. According to the climatologist at NASA's Goddard Space Institute, data based on input from 7,200 different weather stations all around the world. We didn't have that before. 7,200 weather stations stationed all around indicate that the 10 warmest years on recorded record, 9 have occurred since 1996. You all can remember 1996. That wasn't long ago. January and July of 2006 were the warmest on record until now. January 2007 is the warmest ever recorded on record. The U.S. EPA, Environmental Protection Agency, says it's clear that humans have been the major contributor to the rising pollution levels. Now, recently, a recognized study at Georgia Tech, you remember Georgia, stated and cited that the Category 4 and 5 hurricanes have escalated by some 50% since the 1950s, and found rising sea surface temperatures influence hurricane intensity. When Katrina came across the Gulf of Mexico, I had a friend of mine that was there as a scuba diver, and he registered the highest recorded temperature that he had ever registered diving on his dive watch. And when that hurricane came across Florida and it hit that hot spot, the heat, which also generates moisture, provided fuel for that. And if you watched it on television, that was a huge hurricane. I'll tell you another little secret. I have a friend of mine who runs the Hurricane Center in Miami. He put on each side of New Orleans hurricane monitoring, portable hurricane monitoring stations. And he recorded the hurricane when it finally hit New Orleans to be a little stronger than a Category 1. And what you all saw on television was reported a different way. So they really got hit lightly compared to it because it was a Category 5. But in any way, here's what this means to you when you're growing up and you're raising your families. Here's an indirect cost to you. The world insurance companies have seen the U.S. insurance experience a 15-fold increase in insurance losses from catastrophic weather events in the past 3 decades. When you go get insurance on your home, if this thing continues to get worse, you're going to find it's going to cost you out of your pocketbook. On a graph, it looks like this. 1980, here's what they were spending. And now it went here. It just went right up. The curve is absolutely amazing, is what it's done. And it's happened very quickly. In February 2006, there's a fellow named Jim Hansen. He's the director of the NASA Goddard Institute for Space Studies. And essentially, he's President Bush's top climate modeler. He disclosed in a recent satellite study of the Greenland ice cap showing that it is melting far faster than scientists had feared. In fact, twice as much ice is going into the sea as it was 5 years ago. 5 years ago, they declared that ice stable. Now, Greenland is a little place that's kind of up north on the similar parallel as Europe, and it is covered with mile-thick ice. And the significance of this melting that's going on the Greenland ice sheet, it shows that Greenland is losing at least, get this, 125 cubic miles of melted ice a year. A cubic mile, think about that. How far is a mile out here? Make a cube out of it, and then multiply that by 125. That's a lot of water going into the ocean. If Greenland were to melt entirely, it is projected and calculated that the sea could rise as much as 15 feet or more. You can imagine that if you look at all of Miami, Florida, and all those places, the highest point in Miami, Florida is 15 feet. And you come all the way up the coast, and you would wipe out about half of Florida. Once the sheet, this is another thing about global warming, is that things appear to be happening slow, but they can happen fast. Once the sheet starts to disintegrate, it can reach a tipping point beyond which breakup is explosive and it's very, very rapid. The issue is how close we are now getting to that tipping point. The summer of 2005 broke all records for melting in Greenland, so perhaps we're on the edge. Once the ice starts to melt at the surface, it forms lakes that empty down into crevasses on this ice at the bottom of the ice, and you get rivers of water underneath it, kind of acting like a lubricant. Have you ever put an ice cube on a table and it fell out of the glass, and all of a sudden the ice cube just starts moving like it's magic? Because the melted water underneath it makes that little cube begin to slide. This is happening both in Greenland, or potentially happening for a massive amount of ice there, as well as in the Arctic, down at the bottom of the Earth. The NASA scientists have measured this in Greenland, and once these ice streams start moving, it'll happen very, very quickly. Its disintegration can be eruptively rapid. How fast can this go right now? Hansen says our best measure is what happened in the past. We know, for example, 14,000 years ago, the sea levels rose by 65 feet in 400 years. And that is over 16 feet a century. Now, this was towards the end of the last ice age, so there was more ice around. But on the other hand, temperatures were not warming as fast as today. So how far can it go? The last time the world was 3 degrees warmer than today, which is what is expected later this century, sea levels were 82 feet higher. 3 degrees warmer, sea levels were 82 feet higher. Remember, in 1 century, we've already come up 1 degree. So that is what we can look forward to if we don't act soon. None of the current climate and ice models predicted this. Hansen believes that sea level rise is going to be the big issue soon, more perhaps than warming itself. Scientists' latest predictions indicate that the ocean levels could eventually rise as high as 20 feet due to expected warming trends, flooding low-lying coastal areas around the globe. So how long we got? Hansen and many other climate scientists believe we have to stabilize emissions of carbon dioxide within a decade. That's 10 years. Or the temperatures will warm by more than 1 degree. That will be warmer than it has been in 500,000 years. 1 more degree. We cannot wait for new technologies like capturing emissions from burning coal-fired power plants or building nuclear plants, which can take 10 years. That's about how long it takes to build a nuclear plant. We have to act what we have right now. This decade means that we're focusing on energy efficiency and renewable sources of energy that do not burn carbon. If you have energy efficiency, and if you change the light bulbs in your house, or if you put solar panels, or if you pull from wind energy, you change the equation from a carbon-based energy society to an alternative and a clean energy society. Something that can be done. Now, Forbes magazine, it's a business magazine, generally a very conservative publication, recognized that global warming is undeniably occurring and said in November of 2005 that, and they did this from a worst case prediction, that no effort or economic cost should be spared to mitigate global warming. Leaders of the National Association of Evangelicals have issued a policy statement to Congress to enact mandatory carbon emission caps. And several other religious orders have done the same. In April of 2006, Time magazine devoted 35 pages, and they said, "Be worried, be very worried." While the Bush administration recognizes global climate change as an issue, they are avoiding any real action to address the seriousness of our contribution to pollution. In fact, if you look at it, 17 different states in the United States right now have instituted their own energy policy, different than what our own country has done. And this policy is putting into place alternatives that will help enhance the climate for our future. Now, someone was going to help me hand out some things. Are you folks out there? Great. Let's see. How many guys take this? Y'all just hit each row. You know, we've solved this climate crisis before, and there was a time that there was a thing called the hole in the ozone layer, and it had to do with chlorofluorocarbons that we were producing in industry and that sort of thing. I don't know if you all remember that or hear about it, but it was very serious because remember that protective layer that I was talking about that was up there is that the energy where the sun comes through that protective layer, that layer was being dissipated by these different chemicals that were drifting up into the atmosphere. So, what we are hoping to do is to, and what they did do at that time, is that they went out and essentially ridded themselves of the chlorofluorocarbons, and it began to dissipate the destruction of the upper atmosphere. So it can be done when government, business, and the people get behind it. I was thinking about how much has changed in your lifetime while this is you're handing these out. I was told today that in the United States, every 3 minutes, 60 new people are born here. In China, 214 are born. And in India, 351 folks are born. A lot of pressure continuing to build on the climate and on the planet. There are, I think there's some 300 books that are published today. I'm sorry, 3,000 books are published every single day. And that if you read a New York Times for a week, you would know more in the New York Times in a week than you did in the 1800s for an entire lifetime. So you've got all the information, we've got all these things. Okay, does everybody have this map? This is, okay, he needs one. If you've got a map anywhere, just can you all share one there? Great, thanks. This, folks, is the most important map that I think I could show you as it relates to global warming, and perhaps it most poignantly points out what we're dealing with and what you're dealing with for the rest of your life until we figure out how to fix this thing. Now let me explain it to you. Look at those squiggly lines, and the bottom line is a temperature line. It goes up and down. It's white. The top line is the CO2 line. It's in the gray. And then if you look down at the bottom, that's the number of years. So if you look at the number of years on the left-hand side, that is 650,000 years ago. Human beings, depending on your belief systems, started up somewhere around 200,000 years. And if you go to the zero, put your finger on that zero and run it up about halfway up that line, the very last line, that's when Mesopotamia was. And we are just barely showing up on the tip of that graph. So how in the world do we know what the temperature was 650,000 years ago? How do we know how much CO2 was in the atmosphere, the carbon, the emissions, 650,000 years ago? Well, they do that by going to Antarctica. Who knows what the coldest place in Antarctica is? Or what's the coldest temperature ever recorded? Minus 140 degrees. And that happened in a place called Vostok, and that's close to where they got this ice. They went down a mile, and they drilled down in the core, and in the core of ice, each of these years shows up. And there are little air bubbles in this ice, and they can analyze through different isotopes the difference between these and detect what the level of CO2 was 650,000 years ago, what it was 300,000 years ago, and correlate that to temperature. So watch this graph, guys. This is it. This is some of your future right here. 650,000 years ago, look at the lines. They almost mirror each other. Are you getting me? What happens is that when the CO2 level goes up, so does the temperature. When the CO2 level goes down, so does the temperature. You see the white line at the bottom, some of those places where it went way up and it came way down? The down part is an ice age. In Louisville, Kentucky, some 14,000 years ago, if you stood on the bank of the river there in Louisville, Kentucky, you could look across and see 600 feet of a wall of ice. That's where the ice stopped. It didn't get to Fairview. It quit right there. But that happened in an ice age, and that was temperature differential, and that was a natural variability of the planet. What caused these extremes? No one knows. Volcanoes, whatever it happens to be. So the question is, then why isn't this natural right now? Why is it not the fact that the weather goes up all the time, it gets warmer, it gets colder, and that sort of thing? What we've got to look at is where the CO2 level is right now. Look at the gray line, look at the first circle, and that's where we are right now on the number of amount of CO2 that is in the atmosphere. Those little numbers way over to the left are what is called parts per million, and they measure CO2 that way. So we are way above any time from 650,000 years ago. And if that's the case, and if temperature follows that, then we could warm catastrophically. And what the graph further shows that if we continue at the same rate of producing CO2, that the CO2 levels will rise almost twice as much. So what I hope you folks will do is to recognize that we have a global emergency. There are people that are framing it as a moral issue. There are people that are framing it as a human rights issue, because it affects everybody on the planet, everybody on the globe. When you have a drought, you effectively hurt people's ability to eat. We have right now approximately 20 million people walking around with packs on their back with no place to go because they had to leave their home for some reason. It generally began with an environmental issue. You run out of grass for your goats to eat. You take your goats over to your neighbor country. They get mad at you. So they start a war, and before long, somebody's on the move, somebody's getting hurt. And if that happens globally, and it happens significantly, you know, storms are bad and all that sort of thing, and rainfall is bad if it gets too much, and rainfall is bad if you get too little. The fact of it is the climate is in disruption because of the amount of carbon that we are putting into the planet. What can we do? A lot of things. I won't go over everything because my time is running short, but I will show you this, that if every home in the United States replaced one light bulb from what they call an incandescent bulb, that's the one if you grab it, it'll burn your hand, with a fluorescent light bulb, which is quite kind of warm and it's got little squigglies in it. If everybody put one light bulb in the United States, which is called a compact fluorescent light bulb, the reduction of greenhouse gas emissions, or CO2, would be the equivalent of taking 800,000 cars off of the road. In addition, your mother and dad would save money, and when you get your home, you'll save it too. So it makes a lot of sense to me, regardless of where you come down on this issue, that it makes no sense to pollute the planet. We only got one. And my hunch is that if we do this, we will save money, we will save health issues, and we'll save the planet. Thanks.